Hello again, this is Dan Sandler. Welcome to part 8 of our Hadoop streaming social media to Hadoop in the Amazon cloud tutorial. So this is part 8 of 10. Just to catch you up, for those following along, you're already caught up, but everyone else, we have set up our Amazon instance in the cloud, AWS EC2. We installed Cloudera Hadoop, Cloudera distribution of Hadoop version 4. We configured Flume to stream social media, Twitter data using our app that we registered with Twitter. It's streaming to the Hadoop file system. We configured Hive on top of that, so we can get access to that data in a SQL-like manner. And we have Uzi running in the background, so that's coordinating the adding of partitions to our Hive external table so that when new files are available, they'll be visible in the table. Right now, the biggest constraint with the tutorial that came with Cloudera, and it's a great tutorial because, I mean, obviously it gives you a lot of accelerators to stream social media, to get familiar with Hadoop, and to get your hands on the technology. But because it's such a powerful technology, we want to get the most out of it. To limit, right now, the Uzi workflow will, it's going to wait until an hour flips. So if it's 1 o'clock right now, it's going to wait until it hits 2 o'clock before it adds this new partition. The reason why is because Flume writes out to a temp file. So it's streaming data and it writes out to a temp file. If you try to query the data the way the current tutorial is written, and you add the external partition to the external table, as soon as at the minute the data is there, it's going to pick up these temp files in the query, and there's going to be an exception thrown because there's a lock on the file, which MapReduce won't be able to resolve. So we're going to, and again, Hadoop's got it's gaining mass appeal. It's getting rapid adoption in the market, but there's a way to resolve this constraint that comes with this tutorial. Because at the end of the day, social media is frequently changing. It's dynamic. So as soon as the data hits our environment, and Flume is not constraining us. It's the fact that there's a lock on the file and it can't be resolved until we resolve it. We're going to show you how to do that right now. So let me illustrate this constraint. Okay. So right now, Uzi is running. Okay. Hello again, everyone. This is Dan Sandler with part 8 of our 10-part series on how to set up Hadoop in the Amazon cloud and stream social media to it. So just to catch everyone up, if you haven't followed along, at least for every step of the way, we set up an instance in the Amazon cloud. We installed Hadoop in that environment, Cloudera Hadoop distribution version 4. We set up Flume, configured it to stream Twitter data, which we registered an app on Twitter. Stream it to the Hadoop file system. We set up and configured Hive. We set up and configured Uzi. And the last time we left off, we were actually streaming data. Okay. So now what we want to do, and we're at step 8 of this exercise, which is to make the tutorial real time. Okay. The one thing about this exercise, if you take, and it's a great tutorial, what Cloudera has provided, and this is one of the reasons why I went with Cloudera to begin with. So because they have these resources, they have these how-tos, these tutorials that really made it understandable, and this is highly relevant, right? Streaming social media to Hadoop, unstructured data, and having it available for sentiment analysis, that's a big data motherload right there. So, but the one constraint and the one thing that I felt necessary, I was really focused on making this real time, because right now, if you took Cloudera example as is, it will, the Uzi workflow is designed in a way where it will wait until an hour flips. So right now it's 2, it will wait till 3 before it actually adds a partition to our Hive external table. It's because Flume creates these temp files. Okay, so if I go out here, if I look on the file system, and right now it's 14 data start dot tm. It's going to find a temp file. That temp file is going to cause issues, okay? So there's a way around this problem, right? You don't have to wait for the data, and Hadoop is such a powerful technology, and that's one of the reasons why it's gaining so much traction and adoption. To sort of wait for this data as it comes, it doesn't, it seems like it would be an unnecessary constraint to work with, and it is, because Flume streams the data near real time. So it would be great to have it as it lands to the Hadoop file system as opposed to waiting. So let me just demonstrate the constraint right now. Okay, so I'm going to show the Uzi workflow running. Okay. Right now, the Uzi workflow, there's a wait on the next action. It's actually waiting to for the next hour to come forward, okay, before it adds a new partition. It just added the 1 o'clock partition. Okay, so if I go to sudo I'm going to execute show partitions on our tweets table. It's going to list out all the partitions, and the last one in the stack is 1 o'clock. Okay. Meanwhile, it's 2 o'clock. So if I'm on Twitter right now, I'll go here. I'm going to tweet about big data. Let's find a big data tweet worth retweeting. So I'm going to check here on my file system. I'm going to see that we do have that tweet. Yep, there it is. Okay, it's all right there. Big data miss persist right there. So that's all from me, because we grepped it on Data Dance Anna. It's not from the original tweet. So if I go and if I query the tweets table right now, if I say select count from tweets user dot screen name equals data Dan Sandler, and the partition, which is date hour, is greater than or equal to, let's say 21 203 0221 and 1 o'clock. So as this runs, I'm just going to show you what what's causing in the Uzi workflow, there's a cord app XML, this ready indicator. As you can see, the comments in the code that was provided, it says done something a little bit of a workaround. I won't call it a hack. So it says Flume doesn't have a good mechanism for notifying an application, blah blah blah. So basically, that's saying that temp files are going to cause an issue. Okay. And I'm going to show what the issue is, because right now I'm going to edit the cord app.xml. First, I'll back it up. I'll edit it. I'm going to remove this. So those tags, okay, are what keep this wait. See that waiting? That's the reason why it's waiting. It's waiting for the next hour to roll forward. It's waiting for the quote-unquote ready indicator to be set to true. So what I'm going to do is I'm going to kill this Uzi workflow. So the Uzi workflow name is right here. You can get it from the console that we set up in part 8-7 of our series. I'm going to kill this. Grab it. So if I go back to the console, I'll see that this is no longer found. I will then put this cord app.xml file over to the Hadoop file system. Alright, now I'm going to start the workflow again. Now it's not going to wait very long to actually add the partition. It's going to, as I run this again, it won't take very long. Job's already running. So it's 1 o'clock. But this means, see, it already added it. I already added the partition. If I go back here, I should see 2 o'clock. Oh yeah, it actually tried to, the job started using the job start initial data set as 1 p.m. So it actually went ahead, it recognized that 1 p.m. was already here. So the initial configuration started with 1. So the next hour should be running shortly. It will recognize that it's 2 p.m. and it will start shortly. And that's basically what Uzi does. It runs in the background. It will add each partition once it comes up. See, it's already running. Instead of waiting, it's running. Now it's a configuration change we made. So if I go here, we'll see the action configuration has 2 p.m. as the date. It should. Yep, 2 p.m. So we'll wait for this to run. Show partitions. And we'll see 2 o'clock shortly. Right there. Good. Okay. Now here's where it gets a little tricky. Okay, this is where the problem gets in, and that's why the original ready indicator was set in the workflow. Okay. So I'm gonna go here. I'm gonna look. See, there should always be a temp file. It's constantly writing because this is I mean, we're streaming big data tweets, so anything that's mentioned with big data, data visualization, Cloudera, Hadoop, it's going to land here. So there's a lot of tweets going on right now about those topics, and that means it's constantly writing, it's constantly creating these temp files. So if I try to query right now, that same query that we ran before, that we ran looking for my screen name, I expect to see an exception when this runs. The only time we wouldn't see an exception is if there's no temp file. But if I there's a temp file. See how it's taking a little while? Let's see what's happening. Okay, we can all check this out. See? Right there. That's an error. So that doesn't tell us much. So let's look behind the scenes. Okay, that's why we have console here, which is running on the MapReduce job tracker right here. So completed jobs, failed jobs. This is the one that just ran, right? So you can see the SQL that was running. Go to failed jobs. Usually there's a four attempts before it bombs, and it bombs in the map phase of the MapReduce program. See this invocation? I'll make this a little bigger here. This is how you know that this is exactly why they have the ready indicator in the cord app.xml. Okay. So this is where, okay, you could live with the constraint of wait every 60, or I mean worst case it would be 60 minutes, but you know, the farther you are away from the top of the hour, the longer you'll have to wait. Okay. So let's not wait. I think that's the goal. So I'm going to do two things. The first thing is, and by the way, I'm going to post all this particular step of our series in writing to my blog, because a lot of this stuff you could kind of fish on your own. You could basically use the manuals and the tutorials that Cloudera provides. This is one where I couldn't find the one-stop shop of how to exactly do this, what you have to edit, what the steps are to make this work. This is, I think, the one thing that I could add to the discussion here. And I'll post this to my blog, datadanSandler.com, as soon as I get this up on the YouTube. So the first thing is first. So we've already got the cord app XML. That's already been edited. So if you've got that, then okay. How do we make Hive exclude the temp files? So to exclude the temp files, we're going to create. This is if I go back here, this little custom MapReduce path filter. So that's a property of MapReduce, and it tells them to exclude certain types of files. So we're going to actually build, actually with some very simple Java code, we're going to take the Java code, build a even simpler jar, and make Hive aware of, because that's where Hive is kind of the glue in this picture. Hive is going to, we're going to configure the Hive site.xml to exclude Flume temp files. So we need to build some custom code, and there was a CDH Google group, and they kind of provided this as a workaround, and it actually worked like a charm. Okay, So again, this is, I believe, 12 lines, 12 whole lines of Java code. I'm not a Java developer, but I know enough. So let's make a directory called Java. Okay. CD Java. Going to. There's a couple other directories because just have the path of everything. Say we're going to make dir com slash Twitter, make dir com Twitter util. Very simple path. cd com Twitter util. Going to the vi file. The file or the Java class, I've named it as file filter exclude temp files dot java. Going to paste in those 12 lines of code right here. Very simple. I won't worry about putting it up. Of course, the package name corresponds to the folders I've just created. I'm going to go up 3 levels. Going to export this class path. Okay. Then we're going to compile it. So Java C com second. Sorry about that. I realized that I had the wrong version of the jar. My apologies. Should be 3. So we'll try this. So that warning is fine. We'll look to see that. Yep, class file's there, so we can char that up now. So we are going to jar, right, jar, everything under com. Alright. And we can copy Twitter util jar to, I like to put them in lib Hadoop. Okay. And I will make sure that change mod. Alright. So now we need to make Hive aware that this custom code exists. To do that, we are going to edit etc Hive config hive-site.xml. So we kind of did this before where we added this file. This is an auxiliary jar path. Well, we're going to do the same thing. And we're going to add the Twitter util, the path to that jar. Okay. Make sure I have it all nice and neat. Comma, and this. And then there's one more thing we have to do. This is the path filter. So if you remember, this file filter exclude extended the path filter class, which Hive is aware of. It's actually a property here. Okay. So do this over. Take this here. I'll save that. And then I can open up, for some reason my don't really like some of the characters in my OneNote cheat sheet. So that's okay. I have a backup. So we need to put this here. Okay. MapReduce input path filter that class. So once that is Hive configured, we've just basically told it we have some custom code which has a path filter. That path filter is going to tell you to exclude temp files. Essentially, it basically just says anything that begins with, that has a dot, that either starts with a dot, so it's, you know, like a dot bash rc or dot bash profile, or contains dot temp, we're going to exclude. Okay? Or anything that starts with an underscore. So now we have to sudo hls going to sudo service Hive server 2 restart Hive, so that if I run the query that we tried to run before, right there, it should find it. It should run just fine. And this is even though we have temp files in the 2 o'clock hour. We should come up with actually one record. One record, just like we expect. So, I think this is, so, you know, Cloudera did the majority of this work to get me to a point where I can say, okay, let's hack around this environment. Let's make a slight improvement. And while it's a slight code, amount of custom code, configuration change, what comes out of this is a much more capable scenario where we can query the tweets, and it's basically the limit of the time it takes to get to the Hadoop file system, the time it takes Flume to make the temp file an actual file. That's it right there. So we've just made this as real time as possible. There's no reason for the, as I mentioned in the config file, there's no reason for this workaround. This we can eliminate. Okay? So we have 2 more exercises. So in the next part, we're going to actually set up an ODBC driver, start to query this tweets table, and then we're going to finish up with some examples of how you can take this to the next level. From the back-end perspective, how to basically, I will talk to the Facebook integration. It's a very different approach, and I'm also going to talk to the sort of data science portion of this, where we can begin to take this data and analyze sentiment. So some of the visualization and the statistical analysis that we could be done, and the mechanisms that you can use to perform that, at least get familiar with those techniques. So if you have any questions, if you have any feedback, the door is wide open. You can contact me at Twitter at Data Dan Sandler. That's Data Dan Sandler. Or you can ping me on my blog, datadanSandler.com. Take care.